Greetings, I'm Jonathan Spirit, nothing's gonna explode today, and welcome to Age of Engineering Supershorts. I have with me a lot of stuff. Look, a deep hole, and this convenient ultimate hybrid solar panel that I just crafted. I'm not even gonna try to hide this. These are the only IC2 machines I'll need to set up here. Naturally, this ore washing plant requires water. For the sake of cables and beauty, these ejector upgrades are set to automatically output to the top side. Remember, you can set them by shift right clicking on the face of the block that you want your machine to output from. I'm running cables behind the walls, of course. Crushed uranium ore becomes purified crushed uranium ore in an ore washing plant. In the thermal centrifuge. Enriched uranium nuclear fuel, fuel rod. This canning machine is set to canning, and works with fuel rods and enriched uranium nuclear fuel. For this design, I'll only need dual fuel rods. Mox nuclear fuel is made with plutonium. It lasts half as long as enriched uranium nuclear fuel, but it reliably produces plutonium, so it's significantly more efficient. I've hooked up an export and import bus up to this reactor chamber. This is the design for the nuclear reactor. I will link it in the description. It's mostly uranium, but I've put in some MOX fuel, which works the same way, so I can just substitute it wherever I want. Preferably, this whole thing will become MOX fuel, but that'll take a while. For now, I'll just let it do nothing. That process finished faster than I thought. That's why it's time to start Tech Reborn. Naturally, however, I'll need a building. All in all, I'd say this was a success. I used an awful lot of marble, including marble pillars. I used blocks of coal coke and blocks of coal and lead slabs for the flooring. I've marked out places for all the Tech Reborn machines I'll need. I wonder if you can guess what this one will be. And I used obsidian pillars for this side of the room. Turns out glass from flat color blocks is chiselable. One electric crucible, and an electric solidifier. Steel in a crucible makes molten steel, which makes in an electric solidifier refined iron. 8 refined iron gets me a machine block and the H10 trophy. Diamond grinding head, Tech Reborn mixed metal ingots which take refined iron, advanced alloy ingots created in any furnace, and advanced alloys created in the compressor, advanced machine block, macerator, industrial electrolyzer, and industrial grinder. Standard machine casings, reinforced machine casings. I'll need 18 standards and 8 reinforced. This grinder only accepts packets of 64 EU per tick, but the solar panel produces packets of 512. An MV transformer takes 512 EU per tick and splits it into 4 packets of 128 EU per tick. So a machine that only takes 128 EU per tick packets will still take 512 EU. So when I take those 128 EU packets and put them into LV transformers, this industrial grinder will happily accept all that EU. This is a simple design that works pretty successfully. All I have to do is make the multi-block. Layer 1. Layer 2, Layer 3. I'm going to sink this into the floor one because the industrial grinder needs to be in the middle. This tank may look empty, but if you look on the left, it is filling up. We can hold off on this for a while until we need tungsten steel. Instead, what we need is to set up an arc furnace. Behold my Immersive Engineering quote-unquote room. I thought I'd try something different and have industry cut into the beautiful environment. Step 1, power cell. Step 2, crusher. Layer 1, Layer 3. Finally, we can use our engineer's hammer on this block to activate the multi-block. I don't like where this power input is, so I'm going to rotate this multi-block. Now for the industrial squeezer. Layer 1, Layer 2, Layer 3, and you can right-click on the barrel from this side to activate the multi-block. I'll place an engineer's workbench right here. Finally, the arc furnace. Layer 1 kind of blends into the floor. Layer 2, Layer 3, Layer 4, Layer 5, and I can activate the multi-block by hitting this cauldron. Behold! Ruby ore in our placer breaker system makes red garnets and at least 2 rubies. Ruby in a macerator makes ruby dust. 1 industrial electrolyzer. Luckily for us, it has no multi-block, and even though it says it takes 128 EU per tick, it actually takes 512. 9 ruby dust in an industrial electrolyzer makes aluminum dust and especially chrome dust. I have a P2P cable hooked up here. Empty cells, because as it turns out you need 3 empty cells to make this recipe, and a quick 25 seconds. Now we need a way to smelt the chrome. In the blast furnace, that will take an obscene amount of time. In the arc furnace, it will take 5 seconds. There's a problem though. When you place items in here, they don't auto-distribute. So if you stuck 64 pieces of chrome in here, it would smelt them one at a time. That's what these machine frames in my inventory are for. I'm going to use a mod called RFTools Control. The programmer lets you make visual programs that do various things. Behold the closure for cactus, 2 card bases, and a processor which executes the programs. Finally, a node so that the processor and programmer can remotely access other inventories. Here's our programmer. Let's start working. This is a visual programming interface where you connect blocks to other blocks in order to make functions. They're called opcodes. The repeat opcode will repeat a program at a specified interval. You can delete an opcode by dragging it over this red delete opcode button. We'll use these 3 dots to choose how many ticks this program will run on. These little gray things are connectors. They lead an opcode into the next opcode. You can double click to change them. What I want to do is count items internal. To understand this, let's look inside the processor block. These are slots for items. These are slots for programs. If you click the resource allocation button, you can tell the processor which slots that the program inside of this particular slot can use. I'm allocating exactly 2 slots to this program. Count items internal counts the number of items in a specific slot. We'll set it to check slot 0. I've done some experimentation and determined that if you put an item pushing machine onto this slot of the arc furnace, it will only be able to push into these 12 slots. That means an RFTools Control's node on this arc furnace will consider this to be slot 0 and this to be slot 11. So we'll count items internal and put a test for greater than. The first value is what we're checking, and we'll use the function lastInt, which is the result of the last opcode, which is in this case the number of items in the last slot. The second value will be 0. If it is greater than 0, we'll stop and move on to a new check. To do that, we'll use wires to transfer the connection of this greater than test to another count items internal on slot 1, which will test for the same thing. The test opcode sends a red signal if it returns false. So if there are no items in the slot, we're going to count items external. This is how we're going to check if there's an item in the arc furnace. The inventory parameter lets you choose an inventory. You can use those nodes I talked about to access an inventory remotely. We'll call our node arc, and we'll access the downside. Finally, we'll check slot 0. Again, if there's an item in the slot, we'll just go over to the second test. I've added another count items external, which is checking slot 1, and another identical test. If the first slot is free, we'll fetch items from above the processor, only one item, into slot 0. Then we'll push items from slot 0 into slot 0 of the arc furnace. I'll set up the same thing here using slot 1. Now I need a program card, and a network card, and a CPU core, a better one. I'll place the program card in this slot and save it as ARC. Actually, ARC1. Now I'll put in my CPU core and network card. Remember, the network card lets me set up access to nodes, but nodes must be on a network. The command net setup name, where name is ARC here, allows me to set up a network with the name ARC. I've called it furnace instead. Now I can place my node here, and I'll give the channel of furnace and a node of arc. Remember, channel names are case sensitive. Now, when I run net setup furnace, it'll find a node. Now that the program's in, I can test it by just throwing some items into the mini chest. Yes, I put a mini chest here. And behold, they have been distributed evenly. Now please excuse me while I set up several more programs with different slots. Behold! Now to make this arc furnace actually work, I need to fill it with graphite electrodes, which are made in an engineer's workbench with an engineer's blueprint of arc furnace electrodes using 4 hop graphite ingots. Hop graphites are smelted from hop graphite dust, which is industrially squeezed from coke dust, which can only be crushed as coal coke. Unfortunately, this process is deliberately non-automatable. While you can produce 50% integrity graphite electrodes using a metal press, you cannot place them automatically into the arc furnace. Anyway, now that these are here, the arc furnace should start working. And that's it for today's episode. Next episode, I'll work more on Tech Reborn, hopefully so that I can get to advanced rocketry soon. Sorry about the long delay, I've had a very busy month. As always, if you have any feedback, I'd love to hear it. I hope you enjoyed!